This is the Slayer exciter. It's the tip 42C circuit. The L2, L3 coils are placed close together using the 5-turn as a collector. It's going out with through four of the 1n4148 diodes in a full wave bridge rectifier configuration, and the scope is on one direction coming out after the diodes. Set to AC just so that the wave's centered in the screen. But you can see there's voltage is dropping because it's drawing a lot on these little 9-volt batteries. This is the waveform that's generated. Alright, you can load the coil by touching it, drawing an arc, which affects the waveform. But it's curious to note is that it's 54 volts up and down, and we're putting in 18 volts. So off of that 5-turn collector coil, you get that much voltage out. So that's where the curiosity lies in getting more of those, or more of actually the same 8-turn, or maybe I'll skip over that and just wind my own coils, 4 or 5 turns. Set them up in bundles, run them through diodes and see what kind of voltages come off. But this draws a lot, so that voltage on the scope will sag. Sags over time. To 50 volts already. It started at 53-ish. So just stop it. Given the scope setting, let's see. Get the waveform measured. So it's about 357 kilohertz. Anyway, that's the waveform that's being generated. And that wave, incidentally, is bigger or smaller depending on the distance. So if these two coils are close together, we get a greater amplitude in the waveform on the collector coil. If this coil is another 3 inches over there closer to the battery, and there's a bigger gap in between there, this amplitude's like 28 volts. So the proximity between these two coils directly affects the shear that's being experienced, I guess, by this coil as the collector. So that's worthy to note as well. So I think what I'm going to do is I'm going to fab a socket so I can replace the tip 42C with a MJL 21193 and see how that works, since I have some of those kicking around. Anyway, that's what's what.